Hello and welcome to today's video. So I thought I'd share with you how I create dynamic permutations. So all combinations from multiple lists. Now there are a number of solutions out there. Not all of them are dynamic. The ones that are typically use functions that are only available to Office 365. My solution is a little different and it works with both 365 and Excel desktop. I just wanted to start off with this formula. Now it uses int and mod to create the permutations, and you may have seen this formula. It's quite often recommended as a solution, while it's valid in its own right, it does require you to copy the formula down for as many combinations as you need. So in this case we have 3 items in first list, 3 in the second list, so it's 3 by 3. We need 9 combinations. Okay. Now if you can anticipate how many permutations you may have in future, you could just copy this formula down, and Excel will insert blanks for the time being. Likewise, you could do that same with the first list and the second list, and the formula will ignore any blanks. Now, the reason I put this formula here is that my solution is based on this one. I just modified it to make it dynamic. And I'll come back to that formula shortly. So we want to start off by making our lists into tables. Okay, so this is going to make looking up the lists dynamic, right? So to look up a table, you can just put the table name, open the bracket, and then select the column that you want, and it returns every row. So regardless of how many there are, it'll return them all without having to specify a from and to range. Now if you're not the one who's going to be maintaining these, I like to filter these tables because someone else may add duplicates, insert them in any order. They might have a mixture of uppercase, lowercase, have blanks and so on. So I will typically do a filter, select the list, okay, and then only include items in that list that are not blank. And then if there's none, we'll return blank. So this first part excludes blank rows. I also want each item to start with a capital letter, so I do proper. I want the whole list to be sorted, and I want to remove duplicates by doing a unique. And we'll close off the brackets there. So just to recap, proper, sort, unique, and filter to exclude the blanks. And for the second list, I'm doing the same, except because they're states, I want capital instead of proper. Now the beauty of these is that they're dynamic, right? So regardless of how many items there are, it'll always expand and adjust to cater for them. And we can reference them by just doing equals, the first cell, and the hash sign, and there you go. Now, doing this is not mandatory. You can use the tables directly as they're dynamic as well. However, you'll need to modify the subsequent formulas that I'm going to show you. Okay, so the next thing I will do is calculate the number of combinations. Okay, so just to be aware, you cannot do a count on a table. It'll give you 0. Okay, and the same with the dynamic array. So you can do a count A to exclude blanks. Just one thing to be aware of with the dynamic arrays, if the list is empty, it'll return 1, and that's not correct in this case. Right. So what we can do instead is we put an if condition. So if the first cell of this first list is blank, then there's no items, so we put 0. Otherwise, we count the actual array, so the L4 hash. And we do exactly the same for the second list, and then we multiply them together, right, to give us the count. Now, coming back to the formula here, the first index here will repeat each item of the first list as many times as there are items in the second list. So in this case, we have 3 items in the second list, so each item in the first one will be repeated 3 times. And it does so by doing this row minus row of the first combination. So it's essentially finding the combination offset from the first one, and then it divides it by the number of items in the second list and adds 1 and takes the integer. So that part there is responsible for repeating each item as many times as there are items in the second list. Right. Now, the second index does a similar thing, except with the second list. But in this case, it uses a mod, which returns the remainder when you divide the offset by the items. Just to give you an example here, this combination is the 7th one out of the 9. Okay, so its row is 10 minus the first one, which is 4, is 6. So even though it's the 7th combination, its offset is the 6th one from the first. Okay, so just keep that in mind as I show you my solution. So we don't want to have to copy the formula down because that's not dynamic. So what we can do is, by doing a sequence on the number of combinations, we get a list of 1 to 9. So they're all the combinations. We have 9 combinations, we have 1 to 9. But then we take off 1 to give us the offset. So this 0 to 8 would match what you would get with a row minus first row for each one of these. So this one would be 0, the second one would be 1 and 2 and so on down to 8. Okay, and the good thing with this one in column P is that this is dynamic. I didn't have to copy it down. And again, it's a dynamic array, so you pick the first cell hash and it returns the whole thing. So now we have dynamic offset, we have dynamic list 1 and dynamic list 2, and we can feed all these dynamic arrays into the original formula here. Okay. So the first index here, we've got index L4 hash, which is the first list. So instead of specifying the from and to range of the first list, we just have to put the dynamic array. Then we do int, and here's where the magic happens. Instead of copying the formulas down, we use the combo offset dynamic array, which is in P4. Then we divide by the number of items in the second list, and again we use the dynamic array M4 hash. Okay, then we add 1 and we take the integer of that. So that will then look up the items in the first list. And the similar thing happens with the second list, where again we put the second list dynamic array M4 hash, and we're going to do a mod on the combo offset array, P4 hash. So, and then divide by the number of items in the second list. Okay. M4 hash again. We add 1, and by taking mod, we get the remainder. Okay. So that gives us our permutations. And just to show you how they're dynamic, a user comes along and adds product number 5. Okay, we get 12 combos now, and 0 to 11 is the offset. And as you can see, product 5 has been added to the bottom. Now the user comes along and remembers that they need to add product 4. As you can see, 4 has been inserted before the 5. If you use the tables, product 4 will appear at the end. Okay. Now the user decides they want to add a state. So we have ACT. It's in lowercase here, but because of our proper and upper and all the filtering we've done in these 2 columns, you'll see that the combinations now have ACT in capital and sorted as well. So very dynamic there. Now I'll just show you how it excludes duplicates. So if I put in New South Wales, there's no change to the number of items. Just to show you that it actually is checking that row, but it's excluding it. If I now put change that one to something else, it will appear as a combination. Right. Now I'm just going to remove these additions just because my next formula, I want to be able to keep this whole thing on one screen. Right, so here they've been concatenated into one column. If you want to split them, that's fairly easy too. All you have to do is take each index and put it into its own column. So that's the first one, and that's the second one. Very easy to do. Now with 365, you can use things such as hstack, text split, or even a lambda function with text split, probably other methods as well, to, instead of returning 2 separate arrays, it'll return one array that spans multiple columns. Now, while I don't have an hstack in this version, I can try and simulate one because I want to show you a limitation there. So you won't need to do this bit if you've got 365. This is just trying to create an hstack. Actually, I can just do that. All right. So in an hstack, this is a virtual hstack, let's call it. In 365, it will create one array. As you can see, the outline, there's only one blue, but it spans 2 columns. And in fact, I can reference this first cell hash. And as you can see, it selects both columns, not just one. Okay, so it's one array and 2 columns. Now the reason I'm showing this is if you need to look up specific columns of single array that spans multiple columns, then you're going to need to reference the column using the column number. Okay, so we're going to do a lookup of both these scenarios. So the individual array ones up the top, individual arrays, and the single array at the bottom. Okay, so let's do an X lookup, and let's look up product 2. All right, with the individual arrays, I can just look up the product array with a hash, T4 hash, and I can return the state array. There we go, New South Wales. So product 2, the first one that it finds, returns its state, New South Wales, NSW. And with a single array, let's do the same thing, product 2, and let's look up the array, the T15 hash, and as you can see it selects both columns. There's no way I can pick just the first column with this notation. And if I want to return the second column, so if I pick that in hash, it doesn't work. It's not selecting the whole column here. So what we need to do in this case is use something like an index. So index, first cell, hash, comma, 0, because we want all the rows, comma, and we want column 1 because we want to look up column 1. And then we want to return column 2. So we do the same thing, select the first cell, hash, comma 0, gives us all the rows, and comma 2. We want the second column. And that works. Now with 365 you could also use choose col instead of index, but again you need to use the column number. Okay, and the reason I'm pointing this out is because we're using the number and not a cell reference, it's not that dynamic. Now this might not be an issue for you depending on what you're doing, but let's say we added another list that we wanted to add to permutations, but in this case we want the states to be the third column. All right, now I'm not going to create those permutations. I'll just hard code some values in. Okay, and with our virtual stack, hstack, I have to extend the range. So we have products, SKUs, and states for both. Now, if you look at our lookup, you can see that the individual array ones, this would have been an array as well, but the individual arrays still returns the correct state without having to have changed the formula manually. Whereas with a single array that returns 3 columns now, it's picking up the SKU. And of course, that's because we've got the column number, and the column number does not change dynamically. So we'd have to come here, update the formula, and put column 3, and now it'll work. So not a big deal, but just something to keep in mind. Well, that pretty much wraps it up. Thank you for watching. I hope you found this useful, and if you did, please hit that like button. I'll catch you on the next video. Thank you.